Welcome and thank you for joining us today. When a critical server fails, the first question is usually, do we have a backup? The second question quickly becomes, how fast can we get the system running again? That is where standby recovery comes in. In this webinar, we'll explore how Actiphy's standby recovery technology helps reduce downtime by keeping virtual machines ready to start on Proxmox and KVM. We'll look at the difference between vStandby and HyperStandby, discuss when each approach is appropriate, and demonstrate how they can help organizations recover systems more quickly after an outage. Although today's demonstration focuses on Proxmox and KVM, these standby technologies also support other virtualization platforms, including Hyper-V and VMware. Let's begin by looking at why standby recovery has become such an important part of modern disaster recovery planning. Every disaster recovery plan begins with the same event. A critical system becomes unavailable. The cause may be hardware failure, ransomware, an operating system problem, human error, or even a planned hardware replacement. Regardless of the cause, the result is the same. Users lose access to the applications and services they depend on. At that point, the organization isn't thinking about backup software or virtualization platforms. They're thinking about restoring business operations as quickly as possible. The question is no longer what failed. The question becomes how quickly can we recover? A server failure is rarely just a technical problem. It quickly becomes a business problem. Every minute a critical system is unavailable can impact employees, customers, and business operations. Productivity slows, transactions may stop, and IT teams come under increasing pressure to restore services as quickly as possible. The longer an outage lasts, the greater the operational and financial impact. That's why recovery planning isn't just measured only by whether data can be recovered. It's also measured by how quickly systems can return to production. In other words, the real emergency isn't the server failure itself. The real emergency is the downtime it creates. This is where it's important to distinguish between backup and availability. A reliable backup is essential. Without one, there may be no way to recover a failed system. But having a backup does not necessarily mean the business can resume operations immediately. A backup protects the operating system, applications, configuration, and data, but before users can work again, that backup still has to be restored. The system has to boot successfully, and critical services need to be validated. That recovery process can take time. Standby recovery is designed to help reduce that delay by preparing a virtual machine before a failure occurs. Instead of starting the recovery process from scratch, the organization begins with a system that is already prepared to run. That's the difference between protecting the data and restoring the business. The virtualization landscape has changed significantly over the past few years. Changes to VMware's licensing model have led many organizations to reevaluate their virtualization strategies. For some, it's about rising licensing costs. For others, it's about simplifying infrastructure or reducing dependence on a single vendor. As a result, more organizations are exploring alternative virtualization platforms as part of their long-term infrastructure and disaster recovery planning. This shift isn't just about replacing one hypervisor with another. It's an opportunity to rethink how backup, recovery, and virtualization can work together to improve resilience and reduce downtime. One of the biggest beneficiaries of this shift has been open source virtualization. Platforms such as Proxmox have gained significant attention by combining the KVM hypervisor with enterprise management features in a flexible, cost-effective solution. Organizations appreciate the ability to build modern virtualization environments without being tied to a single vendor licensing model. For many IT teams, open source virtualization offers more than lower costs. It provides greater flexibility, broad hardware compatibility, and an active development community that continues to improve the platform. As more organizations adopt Proxmox and KVM, they also need backup and disaster recovery solutions that fit naturally into those environments. From a disaster recovery perspective, Proxmox and KVM make excellent standby recovery targets. They provide a stable, flexible virtualization environment where standby virtual machines can be created, maintained, and started when the original system becomes unavailable. That means organizations can use the same platform not only for day-to-day virtualization, but also as part of a broader business continuity strategy. For our organizations adopting Proxmox or KVM, the challenge is no longer whether these platforms are capable. The challenge is ensuring that backup and recovery workflows integrate seamlessly with them. That's exactly where Actiphy's standby technologies fit. They bridge the gap between reliable backup and rapid recovery, helping organizations move from protecting data to restoring services more quickly. Before we look at Actiphy's standby technology, let's define what we mean by a standby virtual machine. A standby VM is exactly what the name suggests. A virtual machine that has been prepared in advance and kept ready to start if the original system becomes unavailable. Unlike a traditional restore where recovery begins after a failure occurs, a standby VM already exists. Much of the preparation has already been completed before the outage begins. Think of it as a replacement system waiting on the sidelines. It isn't running during normal operations, but it is maintained so that it can start quickly when needed. The objective isn't to replace backup. The objective is to reduce the time between a system failure and a working recovery. Now that we've defined what a standby virtual machine is, the next question is how do we create and maintain one? Actiphy provides two complementary technologies for this purpose, vStandby and HyperStandby. Both are designed to maintain a ready-to-start virtual machine for use when the original system becomes unavailable. Both help reduce downtime by preparing the recovery environment before a failure occurs. The difference is not the objective. It is the source of the standby virtual machine. vStandby creates and updates a standby VM directly from the protected source system. HyperStandby creates and updates a standby VM from Active Image Protector backup image files. Over the next few sections, we'll look at each approach, discuss when it is most appropriate, and demonstrate how both technologies integrate with Proxmox and KVM. Let's begin with vStandby. vStandby creates and maintains a standby virtual machine directly from the protected source system. As changes occur on the source machine, the standby VM is updated on a scheduled basis, keeping it ready for recovery if the original system becomes unavailable. Because the standby virtual machine is maintained in advance, much of the recovery preparation is already completed before the failure occurs. When an outage occurs, administrators work with a prepared virtual machine rather than starting the recovery process from scratch. This approach is particularly valuable when minimizing downtime is a priority. The goal is to have a standby system that is configured, synchronized, and ready to start when needed. On the next slide, we'll look at some practical situations where vStandby can be especially useful. Now let's look at where vStandby is most effective. One common use case is protecting critical physical servers that need to be recovered quickly. Rather than waiting to restore a complete system after a failure, administrators already have a standby virtual machine prepared and ready to start. vStandby is also useful during hardware refreshes and physical to virtual migrations. As organizations modernize their infrastructure, it provides a practical way to transition workloads from aging physical hardware into a virtual environment with minimal disruption. It can also protect important virtual workloads by maintaining a standby copy on a separate virtualization platform, adding another layer of recovery flexibility. In each of these scenarios, the objective is the same: Reduce downtime by preparing the recovery environment before an outage occurs rather than building it during the outage. Now let's look at HyperStandby. While vStandby creates a standby virtual machine directly from the protected source system, HyperStandby takes a different approach. It creates and maintains the standby VM from active image protector backup image files. As new backup images are created, HyperStandby uses them to update the standby virtual machine, ensuring that recent recovery states are available when they are needed. This approach allows organizations to build and maintain standby virtual machines using their existing backup workflow. There's no need to create a separate protection strategy. The backup images already being produced become the foundation for standby recovery. The result is the same: a ready-to-start virtual machine that can help reduce downtime when critical systems become available. In the next slide, we'll look at the situations where HyperStandby is an especially good fit. Now let's look at where HyperStandby is most beneficial. HyperStandby is an excellent choice for organizations that already have a well-established backup strategy using Active Image Protector. Instead of creating a standby virtual machine directly from the production system, it builds and maintains the standby VM using the backup images already being generated. That makes it ideal for disaster recovery environments where backup operations and standby recovery are managed as separate processes. It also allows organizations to create standby virtual machines without placing additional workload on the production system. HyperStandby is particularly useful when building a dedicated recovery environment on platforms such as Proxmox or KVM, giving administrators a practical way to transform backup images into ready-to-start virtual machines. As with vStandby, the objective is the same: reduce downtime by preparing the recovery environment before failure occurs so that systems can be restored to operations more quickly. Now that we've looked at both standby technologies, let's discuss a few deployment considerations. We'll start with Proxmox. Actiphy supports creating standby virtual machines on Proxmox, allowing organizations to use it as a practical recovery platform for both physical and virtual systems. As with any virtualization environment, it is important to plan the standby virtual machine before an emergency occurs. During configuration, you'll define items such as destination host, virtual hardware, storage location, boot mode, memory allocation, processor settings, and network configuration. These settings should closely match the requirements of the protected system so that if recovery becomes necessary, the standby VM can start successfully with minimal additional configuration. In our demonstrations, we'll walk through this workflow and show how straightforward it is to configure a standby virtual machine on Proxmox. Proxmox is one of the most popular platforms built on the KVM hypervisor, but Actiphy also supports standalone KVM environments. When deploying standby virtual machines to a KVM host, a few additional host requirements should be verified in advance. These include ensuring that the supported Linux distribution is properly configured, the required target services are installed, and SSH connectivity is available for communication with the host. As with any disaster recovery solution, these prerequisites are best validated before they are needed in an emergency. Once the environment has been prepared, the standby workflow is very similar. The virtual machine is created, maintained, and kept ready to start if the protected system becomes unavailable. Whether your recovery platform is Proxmox or a standalone KVM environment, the objective remains the same: a reliable standby virtual machine that can help reduce downtime when it matters most. The final deployment consideration is boot points. A boot point represents a recovery state that can be used to start the standby virtual machine. As the protected system changes over time, new boot points are created, giving administrators multiple recovery options. This flexibility is valuable because the most recent recovery point is not always the best choice. If a problem such as corruption, a failed update, or ransomware has already occurred, an earlier boot point may provide a cleaner recovery. Actiphy can automatically maintain multiple boot points, allowing organizations to balance recovery flexibility with storage requirements. During our demonstration, you will see how easy it is to select a boot point and start the standby virtual machine from the recovery state that best meets your needs. Now let's see how this process works in practice. In this demonstration, we will create a standby virtual machine using Actiphy. Rather than focusing on every configuration option, I'd like to show you the overall workflow and highlight the key decisions you'll make during the process. We'll select a protected system, connect to the target virtualization platform, configure the standby virtual machine, and start the standby task. As you'll see, the process is straightforward and follows the same logical sequence you would expect when preparing any recovery environment. The goal is simply to establish a standby virtual machine that can be automatically maintained and ready to start if the production system becomes unavailable. Let's walk through the process. Now let's complete the recovery process. We'll simulate a system failure by starting the standby virtual machine we've prepared. This is where all of the planning and configuration come together. Rather than performing a full restore, we simply select the appropriate boot point and start the standby VM on the recovery platform. The important thing to watch during this demonstration isn't which buttons are pressed, it's how quickly a prepared standby virtual machine can be brought online and returned to operations. This illustrates the core idea behind standby recovery, preparing the recovery environment before a failure occurs, so recovery can begin immediately when needed. Now that we have discussed the concepts behind standby recovery, let's see how the workflow looks in practice. In this demonstration, we're creating a standby virtual machine using vStandby. As you'll notice, the process is straightforward and follows a logical sequence. Rather than focusing on every option or dialog box, I'd like you to focus on the overall workflow. The first step is selecting the system we want to protect and identifying the virtualization platform that will host the standby virtual machine. In today's example, the platform is Proxmox, though the overall process is very similar across other supported virtualization environments. As we configure the standby task, we're defining how the recovery environment should look before a failure ever occurs. This is an important distinction. Traditional recovery often begins after the outage has already happened. Standby recovery shifts most of that work to normal operating conditions when there is time to prepare carefully rather than to react under pressure. Once the standby task has been created, Actiphy takes over the ongoing maintenance. As changes occur on the protected system, these changes can be incorporated into the standby virtual machine according to the configured schedule. The objective is to maintain a recovery environment that closely reflects the current state of the production system. One of the advantages of this approach is consistency. The standby virtual machine is automatically maintained using the same protection policies that safeguard the production workload. Administrators don't have to rebuild a recovery server every time significant changes are made to the original machine. Another benefit is predictability. Recovery becomes a planned process instead of an improvised one. Hardware specifications, storage, memory allocation, processor configuration, networking, and other virtual machine settings have already been defined. When the standby VM is needed, those decisions have already been made. This preparation can significantly reduce recovery time because the virtual machine already exists. Instead of building a new VM, restoring an image, and configuring virtual hardware during an outage, administrators simply start a virtual machine that has been pre-configured in advance. Now that the synchronization has completed, let's see the results. Here in Proxmox, we can see the standby virtual machine that Actiphy automatically created and maintains. At this point, we're no longer looking at a backup job, we're looking at a bootable virtual machine that's ready for recovery. To demonstrate that, we simply start the standby VM. After a brief startup process, the operating system boots normally, applications and configurations are preserved, and the system is ready for use. The amount of downtime depends on primarily how quickly the standby virtual machine can be started rather than how long it takes to restore an entire system from backup. That's the core value of vStandby. Much of the recovery work has already been completed before the outage ever occurs. Now let's look at the same objective using a different approach. HyperStandby creates and maintains a standby virtual machine from active image protector backup image files rather than directly from the protected source system. For organizations with an established backup strategy, this provides a very natural extension to the existing recovery workflow. As the demonstration progresses, notice that the overall process feels very familiar. That's intentional. Whether you're working with vStandby or HyperStandby, the end goal is the same. Maintain a ready-to-start virtual machine that can be used if the original system becomes unavailable. The primary difference lies in where the standby VM receives its information. Instead of monitoring the live production system, HyperStandby builds the virtual machine from the backup images that Active Image Protector is already creating. This approach offers additional flexibility. Backup operations and standby recovery can be managed independently while still working together as part of the same disaster recovery strategy. Organizations can leverage their existing backup infrastructure without introducing an entirely separate protection process. As backup images are updated, HyperStandby uses the recovery point to keep the standby virtual machine up to date. Administrators can also maintain multiple boot points, providing the flexibility to recover from different points in time if the most recent recovery point isn't the most appropriate choice. As with vStandby, the emphasis is on preparation rather than reaction. The more work that's completed before an outage occurs, the less work remains during the recovery itself. Now that the synchronization has completed, let's switch over to Proxmox and look at the resulting virtual machine. Just as before, we see that the standby virtual machine has already been created and is ready to start. Rather than restoring a complete system from backup during an emergency, we're simply starting a virtual machine that has been already prepared. Once the system boots, the operating system, applications, and configuration are immediately available, allowing recovery to begin much more quickly than a traditional restore process. The important takeaway is that while vStandby and HyperStandby use different sources, they share the same objective: Reduce downtime by preparing the recovery environment before it's needed. Which approach is best depends on your environment, your recovery strategy, and how you prefer to manage protected systems and backup images. As we begin to wrap up, let's return to the idea that has guided this webinar. Backup is the foundation of every disaster recovery strategy. Without a reliable backup, there is no dependable path to recovering a failed system. But modern recovery planning is about more than protecting data. It's also about restoring business operations as quickly as possible. That's why standby recovery is such a valuable component to traditional backup. It helps reduce the time between system failure and a working recovery by preparing the virtual machine before it is needed. Backup gets the data back. That brings us to the central message of today's webinar. Backup and standby recovery are not competing technologies. They work together. Backup provides the protected system, the operating system, the applications, the configuration, and data. Standby recovery builds on that foundation by preparing a virtual machine that can be started quickly when the original system becomes unavailable. Whether you're protecting physical servers, virtual workloads, or planning a migration to Proxmox or KVM, the objective is the same: reduce downtime and restore business operations as quickly as possible. That's why we like to summarize it this way: backup gets the data back, standby gets the business running. Thank you for joining us today. I hope this webinar has given you a better understanding of how standby recovery can help reduce downtime by combining backup and virtualization into a practical disaster recovery strategy. If you have any questions, we'll be available in the chat for the next 20 minutes and would be happy to continue the discussion. To learn more about Active Image Protector, vStandby, HyperStandby, and our complete family of backup and disaster recovery solutions, please visit Actiphy.com. Thank you again, and we hope you have a wonderful day.